So again, writing everything out. We've done A as our amplitude, B affected our period, C was our shift, and D is translation up and down. Maybe you can like use letter association to help you remember, like amplitude starts with A. Period and B, maybe. Phase shift, left and right, and down and up. I'm not sure. Maybe that works for you. Maybe not. Phase shift. Maybe, maybe not. And the important thing you have to remember with the B value, right, for sine and cosine, that your period is equal to 2 pi divided by our B value. That's a formula that's not on your formula sheet that you have to remember. So in example 4, we do get the first time the D value comes up only in part C. Part A and B are review. And then what we're going to do in the next section is put them all together. So far we've just been dealing with one at a time. So for part A, y equals 3 sine x. Dealing with 3 sine x, well, what are we supposed to do? We're supposed to describe how it relates. Now the amplitude is 3. This is a vertical stretch. By a factor of 3. That's our describe part. Remember on an exam, when you have describe, you have to use words. Then we're going to sketch y equals 3 sine x. So the first thing we would have, since our amplitude is 3, our graph goes up to positive 3 and down to negative 3. Our period in this one is still going to be 2 pi, so we mark one full period. And after marking one full period, divide it into 4 equal sections. So this is just your axes family. And finally, to graph it, where does the sine graph start? In the middle, going up. So here's the middle, going up to a maximum, down to the middle, down to a minimum, back to the middle. Add arrowheads on the end. Oh, and this one, you know what? Let's just graph it normal. Let's put a line through the domain. Because the domain said to only do it between 0 and 2 pi. I'll show you what that looks like for B. But generally, they'll just ask you to graph one full period or more. And we did that by putting the arrowheads on it. Okay? Because part B is really annoying between 0 and 2 pi. Okay, I'll show you, but I'll show you how we'll normally graph it. So part B. Part B, if we were describing this is a horizontal compression. By a factor of 1/3. That's the description from our transformations unit. Our description from this unit is we can use the B value to figure out our period, and our period will now equal 2 pi divided by our B value, which is 2 pi over 3. So when graphing this, normally, this is our normal type of graph, we would put Our amplitude is 1, so that means our maximum value is 1, our minimum value is negative 1. Our period now is 2 pi over 3 instead of 2 pi. So we still mark some section where a period's going to end, but now we'll label it with 2 pi over 3 instead of 2 pi. And we're still going to cut that in half and divide this into 4 equal sections. And half of 2 pi over 3 is pi over 3. And then when you go to your first tick mark, you now have to take pi over 3 and cut it in half. Pi over 3 cut in half will be pi over 6. And then to figure out the third one, now that we know that one of these ticky marks is pi over 6, we just have to count by pi over 6s until we get to the third one. 1 pi over 6, 2 pi over 6, 3 pi over 6. And if you want to reduce that, what is 3 pi over 6 reduced to? Pi over 2. So there's our 4 equal sections. They look a lot different than they did before because we normally go from 0 to 2 pi in our axes family. But because of the horizontal compression, our period has changed. But the idea of where does the sine graph start? In the middle going up. So you go from middle to maximum to middle to minimum to middle. Add your arrowheads on the end, and we've graphed at least one period. If I was graphing from 0 to 2 pi, I'm going to put 2 pi there, and put 1 up here, and negative 1 down there. If that's from 0 to 2 pi, would you agree that 2 pi over 3 is a third of the way right there? And then you would have to take that 2 pi over 3 and divide it into 4 equal sections. So we figured this was pi over 3, pi over 6, pi over 2. And what we graphed above was one period, which looked like this. If you had to graph it between 0 and 2 pi, we haven't graphed enough. If 2 pi over 3 is a third of this, can you see that there will be 4 pi over 3 will be 2/3, and then 2 pi will be another third. And those are each of these distances are 2 pi over 3. And if each of those distances are 2 pi over 3, and that's our period, that means in this second section, we would need to divide it into 4 equal sections. The third section, divided into 4 equal sections. And your graph continues to go from middle to maximum to middle to minimum to middle to maximum to middle to minimum to middle. And that would be the graph perfectly between 0 and 2 pi. If we normally have one period between 0 and 2 pi, when we compress it by a third, we now have 3 periods between 0 and 2 pi. And finally, part C. Part C was saying, let's graph y equals sine x plus 3 from our transformations unit, that is a vertical translation. Three units up. From our sinusoidal unit, the key thing that we're going to notice that this changes is the middle line, or the average, or the fancy word for it is the sinusoidal axis, is now at y equals 3. In all of our other examples, the middle line has been on the x-axis. But now that we shift things up, our middle line shifts up 3. So what does that look like? We're going to take a dotted line and label our sinusoidal axis. We haven't labeled it yet because it's always been on the x-axis. But if we label our average, our sinusoidal axis, at y equals 3, what is our amplitude in this one? 1. So that means your amplitude is the distance from your center line to a maximum. That means if our center line or our sinusoidal axis is at 3 and we go up 1, our maximum will be 4. And if we go down 1 from our center line, our minimum will be 2. What's our period in this case? Well, the b value is 1, so your period is 2 pi. Mark 2 pi. Divided into 4 equal sections. So this is just your axes family. And now we can draw our graph. And this is where the language that I've been using all the way through becomes really important. Where does a sine graph start? In the middle, going up. Where's our middle now? There. Our sinusoidal axis is our middle. And if we're going up, we'll go middle, maximum, middle, minimum, middle. And so this shortcut is a lot quicker than doing those 5 points and saying up 3 and adding 3 to each of those 5 points and plotting them. Because we can just go from middle to maximum to middle to minimum to middle, following the pattern of the graph. And it's faster than using our old techniques in transformations, where you actually took the points and changed them. If you want to do it the longer way from transformations, that's fine. But especially for sine and cos graphs, you're going to find this makes it so much easier. Okay, questions for practice on this one are 6 and 7.